This is a short lesson on the laws of logarithms. There are three main laws we're going to deal with. The first one, you take two logarithms and you're adding them together. Now they must have the same base. Here we're dealing with base 10, so they're all in base 10s. If you have two logarithms, you add them together, you can multiply your numbers to get down to one logarithm. Same as if you're subtracting two different logarithms, same base, it actually is one logarithm, the number's divided. And the third one is you can bring the exponent down and put it in front of your logarithm. So these first two are dealing with two logarithms and making them into one logarithm. Either adding two logarithms becomes a 1 by multiplying, or subtracting two logarithms becomes a 1 by dividing. So let's do a couple of examples of that. Express as a single logarithm. Log 5 plus log 3. Okay, there's two different logarithms. Now they both have the same base. These are both base 10. It's invisible, there's nothing there, so it must be base 10. So that can be simplified down to one logarithm as saying log 15. Here I have, by multiplying them, that was the first rule. Here I have two logarithms, dividing, same base. Want to put it as one logarithm. This is the second rule where dividing means you can, sorry, that should be a subtraction. Subtraction means that you can divide. So that'd be log 30 over 6. Subtraction means you divide, which is log 5. Third one here, I have subtraction. Subtraction, if I want to put down two logarithms into one, it's going to mean that I'm dividing, but this one is not a logarithm, so I need to turn it as a logarithm. It's a whole number 1. This is base 10, so log 5. That is the exponent. What number would a base 10 would give me an exponent 1? Well, that is 10 of 10. So now I have both same base, but I have expressed this as a logarithm of base 10. Now I can, subtraction means dividing, so that becomes log and 5 divided by 10, which is 1/2. Same again, I have a whole number, but I'm a logarithmic equation. I want to turn that into a logarithm. Now this is of base 2, so I have log base 2 8 plus log base 2 of 2 to the exponent of 2. This is the exponent that would have happened on your 2. Okay? So that would become log base 2 of 8 plus log base 2 of 4. Now I'm adding, which means I can multiply to get down as one logarithm of, and that would become 32. And log base 2 of 32, well hey, I can simplify that because 32 is 2 to the exponent of 5, and so my answer is simply just 5. Lots of more examples we can do with this stuff. The next one, to keep on going, simplify down. So the third rule said if you have an exponent in front, you can take it up. So I have log 2, and that becomes the exponent of 4, plus log 3. Okay, so log 2 of 4 is 16 plus log 3. Adding means multiplying. So multiply 16 times 3, which is 48. Now I have down to one logarithm. Again, I have a whole number in f. I don't want a whole number, I want it as a logarithm. Now it's a whole number of 1, so that these are all base 10. So that becomes log 10 to the 1, which is just 10. Minus log 2, bring this up to become an exponent. It's log 20. So I have log 10, which is my whole number, turned into a logarithm, minus log 2 exponent 3 is 8, plus log 20. Now I need to do dividing and then multiplying for the subtraction and adding to get it all down to one logarithm. So it's going to log, I'm going to have 10 divided by 8, and I'm going to have times 20. Okay, which is going to give me log 200 divided by 8, or 100 divided by 4, which is also 25. Okay, simplify without using a calculator. Now these ones, I'm going to change these in so they have a common base. So 81 and 27, the common base I could use would be 3. So I have log 3 to the exponent of 4 over log 3 to the exponent of 3. 3 exponent of 4 is 81, 3 exponent of 3 is 27. Now I can take my exponents down in front. That is the third rule of the logarithm rules. Now notice I have log 3 over log 3. There's nothing else going on there. They cancel out, and I'm simply left with 4 over 3. Same as here, I have log 8 divided by log 0.5. Well, 0.5 is 1/2. So I really have log 8 divided by log 1/2. Expressed as both the same power. Well, the power 2 would be the one to use for 8 and the 1/2. So I have log 2 cubed is 8 divided by log 2 to the negative 1 would be the 1/2. Bring your exponents down front. 3 log 2 divided by negative 1 log 2. My log 2's cancel. I'm going to end up with 3 over negative 1, which is just negative 3. Keep going, the same theme. Show that log 500 equals 3 minus log 2. So I have to show that. This is the left side, right side. Left side, right side. The right side gives me more options to work with. So let's turn this whole number into a logarithm. It's number 3. So it is base 10. So it's log base 10, 10 cubed. The 3 is the exponent. Minus log 2. 10 cubed is 1,000. And base 10, I don't need to write it down. So it's log 1,000 minus log 2. Subtraction means to divide. That's going to give me just log 500. And that is what I was going for. Left side is equal to right side. Okay? Same on this one right here. Now I have both give me options to work with. I'm going to say the right side gives me more options. So I'm going to work with it. And let's bring the exponent up top. So I'm going to log 2 to the negative 1/4. Now 2 to the negative 1/4. I'm sorry, it's log, and it's 1 over 2 to the positive 4. Elevator rule, so log, and that gives me 1 over 16, and that's what I was looking for it to equal. So left side does equal right side on that. And write the following as logarithmic equations. So as a logarithm equation means something I'm going to insert logarithms in. So I'm going to insert logs onto both sides. Okay, now I want to break this side apart. So dividing, if I'm breaking apart, I can turn it into 2 different logarithms, which would go to subtraction. It's kind of working backwards from what we did earlier. And then I can take my exponents and put them in front. And my exponent for this one would be 1/2 because it's square root. And there I have a simple logarithmic equation. So this time I actually wanted to insert the logarithms on both sides of the question, which is the exact opposite of what I want to do for the last question here. Write the following without logarithms. So here I want to get rid of logarithms, so I need to get just 1 log on either side. Okay, so I'm going to put down just 1 log on either side. So log P equals log, dividing means, subtraction means dividing, log Q over, now I could, that 3 come up and become an exponent, so it's over R cubed. I have 1 logarithm on either side, I can cancel them out. So P equals Q over R cubed. Without logarithms. You want to write it without logarithms, get 1 logarithm on either side and then you can cancel them out. Okay, and that's where those logarithm rules come into play. And the last one here, it's kind of a weird question, but if P is this, Q is that one, R is that, express log base B 45. So I need to break that 45 up into being multiplies at 2, 3, and 5. 45 is 9 times 5 is 45. Okay, that helps me. I need to use just 2's, 3's, and 5's. Okay, so that 9, well that 9 is 3 squared times 5. 3 squared times 5 is 45. So I have log base B of 3 squared times 5. Now that's all one logarithm. So break it up into multiple logarithms. Multiplying means adding. And then bring my exponent down. And now I have a logarithm equation involving these, p, q, and r, so I can do a couple little substitutions in here. So I have, let's see, I have log base b of 3, that is q, so I have 2q. I have log base b of 5, that is r, so plus r. So now I've expressed the entire thing in just q's and r's. I didn't have a p to worry about there, so no need to worry about that. Anyways, this is a long lesson on the laws of logarithms. There are 3 main ones to use. You can use it to simplify, break down 2 logarithms into 1, or it helps you as tools to help you solve equations. Thank you very much.